Jag har ju det här ovanan att sätta klockan 9. Där allting annat startar klockan 9:15. Okay, come on. Okay, so we're starting in a minute or two, but let's make sure that you can hear me. Awesome. So I was thinking about what to do today, because now more or less most of my lecture material is already completed, right? So, and I was thinking maybe we should, look into at least one test suite for a project that I know, and then also do some live coding. But I think that might be a good idea to have like a short questions and answering session first. That was what I was thinking. So I think that we can start with some general questions or whatever questions you have. This is better layout then. So this week we're going to have examination of assignment 1, part 2. And that those examinations are oral examinations where you, or those of you who want to do it, signs up for an oral exam with me. It can be either online in my office or in Växjö. One of the sessions are in Växjö. And it's going to be a half-an-hour session. And during that session, we are going to talk testing or test-driven development and unit testing frameworks, mocking frameworks, and essentially you should be prepared so that you can answer the questions in the on the assignment. So maybe just take a look at the assignment. So even if you worked as pair, it's individual examination. And that. And So in order to prepare for this, we want to have make sure that you've done a little bit of TDD. It's quite slow in the beginning, so I've set some requirements here. Actually, these things are not that important as you learning stuff. So this is, think of this as an oral exam more than that you know done an assignment and I need to get something working. So of course we try to get stuff working, but more important than that is the testing knowledge. So you should be able to show expertise in the use of the unit testing framework, the mocking framework, and the coverage tool. And you should know how to mock and understand, all these things related to writing unit tests. So yeah, and then I've also written a couple of questions here, and I think most of the questions here can be discussed. So don't regard these as super short, just one simple answer like what is a unit. You can discuss that, right? So it can be bigger things than just a single method. But in the context of unit testing, it's most often a single method. But we can discuss this further, because if we want to have orthogonal tests, so that each test tests just one specific part of a method, it could be that part of the method that we are focusing on. Yeah, so the same for the other ones. So yeah, they can be discussed. So you can expect a couple of these questions on the examination. So there is a Git submission form where you can submit, or where you should submit your Git repository before the call. And I hope this is the, I'm not going to open it here because it shows your names. Yeah. During the examination, I will, put scores on different things. So how well you know TDD, how well you know the unit testing framework, also a little bit on the complexity of the project itself. So if you don't have 4 classes with dependencies, then you probably have not learned as much as if you have done a more complex project. If you don't have a user interface, then you've not learned so much. But if you have a user interface and you've learned how to test that, and you also handle dependencies, yeah, so that counts. And then we're going to talk about code coverage and mocking, and also these study questions. I mean, the study questions are a little bit covering all of these. Yeah, and then I grade depending on the answers of all of these. And I know that a lot of students get really nervous when it comes to oral exams. And I think that think of this as a tutoring session with me. Try to lower the threat factor. I'm hopefully not going to stress you out so much. And tell me if you're nervous, right? It always helps to then maybe I can also help a little bit. So okay, any questions on this part? Or the other assignments? So a couple of the questions from the Slack channel. I know I've said this before, but if you are still trying to have trouble finding a project for A2, not all projects have good documentation, but it should have good enough documentation so that you can understand the project still. Some understanding of the project can be, done by running the program itself. So yeah, so some projects are can just be the specification of the project can just be derived from running the program. Like if you're examining a word processor, you've all used word processor, you know that you should be able to write them and should be able to create a paragraph and should be able to create a title and stuff like that in the word processor. The specification or the thought of specification for a project is not easily retrieved from just the executable. I mean, there could be requirements that they still have not implemented. So maybe it is, you don't get the full image or the full vision of the project from the developers that way. But you could still have fill in the gaps yourself, right? So if it's a word processor where you cannot create titles, maybe that should be one requirement that is missing right now, that is yet to be implemented. So you can still, imagining a little bit about the should be requirements. As long as you're reasonable, you can do that. Okay. So thinking that maybe we have another question. I'll get another question that on assignment 1 part 2, it says almost 100% test coverage. So if we're doing this assignment, we with almost 100% test unit test coverage, that would be around 100%. It could be 99% or 95%, but you should have a good knowledge on why you have still some percent not covered by any tests, and you should have made an effort trying to get 100%. I would probably guess that if you get 80% or something like that, then you probably have not done TDD in very small steps. So if we are very early on writing the final software, this final version of the software, we cannot add more tests in TDD, or if we're strictly following this red-green refactor, because you're only gonna add tests that make your application fail, or tests that fail, in order to get to red, right? So in TDD, you always go to red first, and if you have a working version of the program, you cannot go to red because it should show green. The correct version of the system should show green. I also got a question on, is it possible to verify that a constructor makes a call to another method? So this is a mocking hen and egg problem, I guess, where we have some hard to test code. So maybe we can just create, I'm going to open the other. And we're going to just for the lecture, create some code. And folder, lecture. And in this folder, we create a new file, a.java. So create a new class. And then we have a constructor for that one, public a. And then in this one, we call a method. And then we generate this method, quick fix, create method, method call, like this. So the question is, can we check if this method has been called in the constructor? Problem is, if we try to test this, notice that I'm not really doing this TDD now. I'm going to create a folder, lecture. I'm going to create a unit test for this one. A tests Java. And let's create test void should call super short memory should call method call should call method call when constructor in constructor. Something like this. And then we need what is called a spy in a mocking framework in order to, so if we are gonna mock our own class, if we want to check a behavior of our own class, then we need something called a spy. So I'm just gonna Google Mockito spy, and I'm just gonna check on how we create the spy. So here we create the system under test, and then we create a spy for that test using the mocking framework. So this is the syntax for that. So just write spy, and then you send it the actual object. So let's try to do that. So var system under test equals new a, like that, and then we can write spy on SUT equals spy SUT, like this. And this is Mockito spy. And now we theoretically, if we had I'm going to write another test first, just to make sure that everyone understands what a spy is first. And we're gonna go here, public void method A calls method B. Too many names, and we're gonna have it like this. So we have a dependency between these two methods. So we're going to have this one, this behavior. So in one method, I'm going to write method A. Method A calls method B. And we want to make sure, using a mocking framework, that it does. So I'm saving that one, and we're going to write method A should call method B. So we want to test that, and When we've created our spy, we call the method that we should method A, we call that one because that is exercising the system under test. And then we verify on the spy, and I need to check the syntax for that again. Write like this. So yeah, that's how I do it. Verify, and you send it the mock object just as a normal mock, but you send it the spy then. Then you make sure that method B. And this, let's just try it out, see if it works, and it's passing. And if we're going into this one and we remove this behavior, it should fail. Sorry. Then it should fail. And it fails because now the method B is not called. So this is a test on the class itself that it calls another method within the test. So if we go back to this one and we make this a private method, I'm not sure if this can be done. Now we have hard to test code just because we have a private method. And this is, I think, one of the interesting test problems when it comes to Mockito. There are ways in some test frameworks around this. So, for instance, you can use reflection and stuff like that in order to still test these things. But this is problematic or hard to test code when stuff becomes private, because you need to test code through its public interface. We can go more into that in a second or two. I'm just gonna check this or do this again. Just run these tests. And now, if we do the same thing here for the constructor. So in the constructor, we are doing we're calling this method called method call. I'm just going to call it method C instead. Let's go into that, and we want to test that the constructor should call method C. Yeah, I made it private, so we need to make it public. This is not good. Not really a good solution to the private problem that you're making stuff public. So, okay, let's try this out. And we run that test, and it fails. Even if the constructor now does call method C, we cannot see that. And the problem is like this. Here, we are calling the constructor. So method C is called on the actual system under test object. And then first afterwards, we are spying on the object. So this is hard to, calls in the constructor is hard to test because of that. I would probably have some other kind of test for the constructor to make sure that this has been called. I would probably, do what I would consider an integration test instead. So we are instead asserting something about the system under test afterwards. So we are going to check if get field, and we want to assert something about that. So let's assert equals And we have the expected first. So I'm just making this up, but let's say that we have a field. We go to this class and we public void get field, and we say return a. It should not be a void; it should be an integer. And in method C, which is called in the constructor, we set this integer to a number. Like this. So now we have some state really set here in the constructor, and we and we are testing that the method C has been called by checking that the field has been set. So we're really checking that method C has been called. This itself may not be an optimal solution to it, but I think that, and this should of course be number 3 then. And then we don't need the spy at all in such test. I'm guessing that if you're testing that, you get a database connection or something like that in such a method, that is probably not as easy to test as this one. Okay. Where did my StreamYard window go? Is this one? Okay. Did any of that made sense? So methods called in the constructor is hard to test with spies at least, but we can test their actual behavior. Okay. So I was thinking today that we were gonna do a little bit of live coding, and it probably is gonna be like this, that I'm gonna make stuff up, and we're gonna solve the problems that show up. So the idea is that we're gonna create a guess the numbers game, because I guess some of you have seen that before. And guess the number app test, Java. And we're gonna have test cases. And if we're gonna write test first and do this test-driven development way, at least some of the testing today is going to be test-driven development. We need to create test cases before. So running the game should show a greeting. So that is going to be my first test, which essentially this is going to be a console application. And when I start up the console application, I'm going to get, essentially hello world or game started or something like that. But right now, I don't have any system code at all. So I'm just going to make this up. Var sut equals new guess the number app. And then this class does not exist yet, but I'm going to create it, and I'm going to create it in the source folder. Now we have that one. And I can, without breaking test-driven development, make these switches to create the system under test, because I had an error here, and that error counts as red. But usually I try to avoid going to the system under test early on, and I try to stay just writing the tests. Okay, so we're gonna run the game. And I create a separate method called run instead of calling the main method of this class. This app class probably has a main method, but the main method is going to have very little code in it. So I'm going to test that part manually. I'm going to start the game and test that manually. So, but here we try to run the program. And we want to be able to test that something has been outputted to us. So something that outputs anything to us in a console application or in a web application, or I call all of those things that produce some kind of output, I call those views. So in order to test this, I would like to verify something on a mock object. I call it view mock. And I'm still in design mode. So when I'm writing this test, I'm actually making stuff up. So this view mock is going to be sent into the constructor because the app consists of a view and probably a model and probably a controller also. So I'm going to send it, or yeah. So I'm going to send it the view mock, and I'm going to call, make sure or verify that a greeting has been, a specific method has been called on that view mock. Show greeting. I'm going to call that. So now I need a mock object of the view. View mock equals mock. And now I am calling it guess the numbers view. And this does not exist either. So I'm going to the that. So we're gonna add static imports for that one. And I'm gonna create a constructor in the class that takes a view mock. And I'm gonna make sure that there is a method called run in that. And I'm gonna make sure that the guess the numbers view has a show greeting. So now the test is essentially saying that, okay, we're creating an app and we're dependency injecting the view mock, the view into the app. And when we call run, this show greeting method is called. I've not really written any system code yet, but I can still run the test. It should fail because I have not written any code. So now we are in red. This fails. If I am doing the assignment 1 part 2, I would now git add git commit -m red. I'm going to now I can write the minimum amount of code that would make this test pass. So I'm going to the lecture, guess the numbers app, and I'm gonna call this the view, and I'm gonna save that. This view equals view, and this method should called show greeting on that view. And this should be a field. And I'm guessing that is the simplest version that actually fulfills that test. We can go back to the test and run the test again. It succeeds. I can go to terminal now. I am in green. Now, red-green refactor in TDD. So we can refactor the code. I can make the test a little bit more beautiful or cleaner. I can check the different classes that I've created. I can, remove stuff that we don't need anymore. The A class, for instance, and the A tests. Those are not needed now. The guess the numbers view, I'm not really into, working with that yet, so I'm not going to do anything in that one. Okay, so that was my refactor part. So I'm gonna and this behavior of doing git commits is just for the assignment 1 part 2. It's not a part of TDD itself. Okay, when we do commits for A1 part 2, is it really just enough to just put red with no message? Because so far I have always added a proper message alongside it. I think it's really good that you put a message beside it, because then you can find your commits later on. And it also shows stuff. I'm in lecture mode, so I may not think properly, right? So of course we should write good commit messages, but you don't necessarily need to for these small commits. I would like you to stay testing. So, but it's really good that you do it still, because I'm going to ask you to find good, examples of TDD. And just to make sure that you find those within those, a couple of 100 commits or so, makes it much easier. So I don't mind you putting better commit messages. Okay, so I think the best thing that I could do right now is to test the view, because I have a method now that doesn't contain any code. This method that does not contain any code is a bit dangerous, because I don't have any test or any mechanism that says that this code is wrong. So one way of, if I'm going to delay implementing this, I would throw new exception here. Like this, and now I can leave this. Maybe I want to have like this, to do implement or not implemented exception or something like that. So now I can leave it and continue to work on the app if I want to. Okay, but we are gonna test this show greeting, and I'm gonna go to guess the numbers and write a test for that one. Yes, and let's write a test for the show greeting. Show greeting should system out greeting. Okay, so we want to have a system under test. An object we should call the method, and we want to verify something about the about this. So my suggestion is that we try to verify whatever is writing we try to verify that a print line call has been made. This itself is a bit may not be as easy as anything else, but let's see. The pattern from the earlier thing is that the view itself is gonna, inside it's gonna have this system.out.println, like hello world. That is the behavior we want to see inside this, if this is the correct version. But since system is a static call, or it's global, it's static, it's hard to dependency inject this. So one idea would be to take this stream system out and dependency inject it here, and then we mock the stream, and then we can check that print line has been called. Yeah, so let's try to do that. So we have some stream out stream mock, and this, I think this is a print stream. Equals mock and print stream dot class. And we dependency inject that one. Oh, what happened? Like that. We dependency inject the output stream mock, and now we can verify stuff on the mock object. And again, I am designing my code. So when I'm writing the test, I'm deciding how the code should work. We create a constructor. Yeah, we don't need the exception thrown because that was the unimplemented exception thing. So now we have a test. So we are mocking the output stream, we're sending it the output stream, we're calling, executing, or exercising the system under test, and then we're verifying that we get the behavior we want. We can change this string now into something that is more appropriate. So let's say that welcome to play guess the number, something like that. You run the test, it should fail. I would make a commit if I was working on the assignment. Now I'm not working on the assignment, so I don't need to do that. We can go into the view now, and we, it's not a mock, but we are saving this one. Let's just call it out to make things a bit shorter. We create a field, we write out print line, call print line on that one, and I can, we can see that I didn't fully implement it. I can copy the string that it wanted. I can place this here, and then I run the test, and hopefully this is green now. Awesome, I got the behavior that I wanted. Let's go to refactor. We realized that this string was now copy pasted into and is shared between the test and the system under test code, or the system code. So we would like this to be removed and to be only in one place, this string. So one way of doing this would be to remove it from this one and have it as a constant or public constraint in the system under test. So let's say greeting, like that. Quick fix, constant greeting. Now we go to this one, and the greeting should be that, and we should have greeting here. Okay. Oh yeah, it should be a string, I think, instead. Run the test again to make sure that it works after this has been changed. So, oh yeah, this needs to be accessed in a static way, so we should be like that. Fine. Run it again, or actually run all the tests. I should really, run all the tests of the lecture and make sure that I didn't destroy anything. Right now, I would, since I have now behavior that should happen when I start up the application, I should start up the application also. So I would like to run the application. And we're starting the old MyMath stuff because we have not configured the application and we don't have a main method. So I'm actually in red now. Made sense? I'm not writing a unit test for it, but I'm still in TDD mode. So I'm manually testing. I'm starting the application. I see when I start the application that I get to red because I get the wrong expected behavior, or the actual behavior is not the same as the expected behavior because I'm running the MyMath. So let's go to this one. The main class should now be guess the numbers app. And that guess the numbers app needs a public static void main string like this. I can try it out and make sure that it something is wrong. What is wrong? Does not find the guess the numbers app. Yeah, it's because it's called lecture dot. That one. We run it again. Yeah, it worked now, but it didn't show anything. It's because run is not called. So I'm gonna create. I might do what I think is quite ugly, but still we could do it like this. Something like that. Yeah, I need a view also. View equals new. Guess the numbers view, and we need the output stream that should be used here. And this one should be sent the view. Actually, I'm going to divide this into into a variable still. Var app equals that app.1. Now I'm expecting green, which is that I get this welcome message. The greeting is done. One could argue that I'm writing a lot of code here, and that code is not properly tested. So this part, but if anything is wrong in this code, I would not get the expected output here. And also, I don't have an automation right now of this test. I could try to create that. I could, try to run the application somehow automatically and then assert that welcome to play guess the number is outputted. I'm not going to do that now, but one way of doing that is to have a test for main. Let's do that. Let's try. Test void main should output things, something like that. And now if I'm just calling this one, we're going to have an empty. Let's do it like this. Or argument. That. Okay, problem now is that the constructor itself, we can see if this runs at all first. It runs, but I don't have any asserts. So in order to have asserts on this one, I would need to work with the system out. So let's create a print line mock. I'm going to go into the view and I'm going to view tests. This one. I still need an output stream mock. And before running this, I can replace whatever was in the system out with this one. This seems that it's not allowed, cannot be assigned. Maybe there is some set. There is a set output stream to that one. And now I can verify, just as I did in the view tests, that the greeting was called. This test itself is not a unit test. This is a system test. I'm running the entire application now. And this means that if the application has behaviors, I need to, think of the application as a black box. We probably need to remove this test afterwards, unless we come up with a good way of running the entire application. I'm doing an end-to-end test here. I'm running the entire application through its interface. So I'm manipulating the application through these input and output streams. And we might reach a point where this is not possible, depending on how we create things. Okay, so this should now work. A problem with this one is that we change the state of the system out. So if I run more tests after it, system out is not what it used to be because I've replaced that one. So it's probably a good idea to do it like this, to have a print stream, old stream equals system.out. And then after running this one, we can set the, or reset the state. So we prepare for things up here, and then we run it, and then we reset the system so that it works again. So okay, that went surprisingly smooth still. Okay, what is the next expected behavior? We would like the application, when we run it, it should first show the greeting. That should only happen once. But then it should have some kind of game loop within it where it asks us to input a number, to guess a number. Let's go into app tests, and we can copy this one. Should ask to guess number. It's still going to be a view mock, and it's going to be a new method that we call, and we can check that it has been not yet called, and we can go to the app, and now we call it. And I'm deliberately putting it before, because this is the wrong behavior, right? We want to have the show guess number to be called after the show greeting. But I now run this test. I can run all of the tests on this one. They all succeed. Now I want to go to I get a question. JUnit doesn't have a restore all mocks or similar that can be used instead of reassigning the original methods. I don't know, actually. I'm uncertain on how it handles this. Okay, now I want to understand, or I want to learn, actually, how to test that these two methods had been called in a specific order. That show guess the number is always called after show greeting. I know that in Mockito we have something called Mockito in order. So let's go and look at that one. So here we have an example. I'm just going to copy the example and paste it into our test. And let's copy paste this test. Show guess number should be called after greeting. That is our new test. And we only have one mock. And we can now verify stuff on the in order object instead. And the things that we want to verify is that show guess the number is called after the show greeting. Okay, something. View invalid assignment operator. On token show greeting D. Literal is not properly closed by a double quote. Okay, maybe that was just bug. So I run this new test, and we can see now that we get a verification in order failure, that it is not in this order. And now I can go to the app and fix this. So that show greeting is run first and show guess the number is called second. I can now run this and make sure that it works. And all of these tests should now work. And we go to refactor. And what I realize now is that this test itself checks that show greeting has been called and checks that show guess number has been called. So both of these tests are now redundant tests. I don't need them anymore. I remove them. Now I have one test for both things. It's, if you've read the course literature, it says that you only want one assert per test. So if I'm doing this thing where I create two asserts in a single test, that is sort of not by the book. And we want to have one assert or one verify per test in order to make sure that the accuracy of the test to pinpoint what is the problem to us as programmers to be as precise as possible. If we test more things, we don't know what things broke. But in this particular case, I want to test that this method is called and then this method is called. So I cannot really avoid testing more than one thing. Make sense? So every time we have some kind of rule from the book, there might be cases where we need to break the rule also. This was, and I'm just going to clean up stuff after that one. So show guess number should be called after the greeting. We run all the tests again, and they succeed. And now I can go to the view and create a test for show guess number. So let's go to the view. We copy the test that already exists. Show guess the number. It's going to work the exact same thing with an output stream, and we are going to call the other method ask. What was it called? Don't remember. Show guess the number, and we don't want the greeting to be shown. We want the ask for number, and I go into the view, and now you see that I skip steps because I already know how to do these things. Sometimes when I'm copy pasting guess number between 1 and 10, and then I'm gonna have a semicolon like that. And now I can go to the test. I run this. This one should fail. I go to the implementation. I make the simplest implementation that succeeds both tests. And we're going to have a break. Okay, so we're starting up again. And I got a question, but I didn't fully understand the question, Jimmy. So maybe I want to have the question in code, because I fully didn't understand this. Can the entire system class be marked with a sub-object out that has two methods print lines that pushes s into an array and get prints that returns that array? I think I need it in code. Okay, so a problem now that I get back to this code is that I don't remember where I was, because we coded a long time ago. So I would prefer when I get back and I run all the tests to have a test that fails. It would be really, really nice if I had a test that fails, because then I could know exactly what I should do when I get back. So I think that should be something that we try to remember to the next time. But so usually the way that I get back is that I try to run the game. That means manually test it. And okay, I play to guess a number between 1 and 10, and then nothing happens. The app closes, the game closes, and I'm not able to input anything. So now I have an idea on what to do next, because we should input a number. So let's go to the app tests. And let's add a new test where we are forced to input something. Okay. Okay, so if this is guess the number and we guessed the wrong number, then we should be asked to guess again, right? Right now, I'm not trying to be too smart and overthink things. I just try to, make a simple test. Should ask for a number twice when on wrong guess. On wrong guess. Okay. So let's just use, I think that we don't need the in order. And then we just do normal. This one, normal verification, not in order verification. And I want to verify. And if I remember it correctly, we can have a verification mode on this one, but I don't remember exactly how to do that. So I'm gonna verify Mockito verify times. I'm just gonna Google it. So we can see from this Stack Overflow, we can get how many times. So as a second parameter, you say that at least twice or exactly these many times. So that seems suitable for us. So times 2 times. Show guess number twice. But now I need some way of inputting things. I need some way of being asked stuff. And I also need to have the behavior where we are guessing the wrong thing. So one way of doing that could be to let the configure the view mock so that we are actually getting a number. So let's do that. before this, we when viewmark dot get guess, that does not exist yet. Try to create that one. We need when, then return false guess. So let's say that the false guess is 1. Then we need to make sure that false guess is different from the correct guess, so I must input the correct value, right? And correct guess equals 5, something like that. I could input it into the guess the numbers view, not the guess, yeah. Am I in the, no, I'm in the app now, not the guess the numbers view. I want to have it in the guess the numbers app. So one could think of, is it a good idea that a game gets the correct number in its constructor or not? We could ponder on that. I would prefer to write this in as a model view controller application. And then I would call the app as a controller, and I would need a model. And the model contains all the rules for guess the numbers game. So I'm just going to invent another mock that contains all the rules. And instead of having, wrong guesses, correct guesses, or something like that, I can configure this model mock to say that this was wrong. Whatever was inputted was wrong. Yeah, and I want to make sure that it's created in the right new file. And okay, so this one now, change the constructor add parameter. Yeah, then return false guess. Maybe. I'm gonna do it like this. So, okay, so I'm thinking and I'm designing this, and this makes it hard for me to tell what I'm doing really. But I'm thinking like this, that now we have a model, and the model should tell us if a guess is correct or so. And maybe we have a method inside the model that check if a guess is correct or not. We call that is correct. We send it a number, a false guess. I'm just putting a number into that one, 10. And is correct is going to return false when that happens. Yes. And I still have not really changed the system code. I'm just, thinking how should this work internally. So in order to do these kinds of tests, I need a strong model on how things is going to work inside it. But the model itself is going to have the behavior to check if a guess is correct or not. And then we can ask it, is a specific number correct or not? Then it's going to return false. And then I run this, and then I verify that the show guess number is called twice. Okay, so I'm going to run this and see that it fails. Should ask for a number twice on wrong guess. And now I go into the app, and you can see that the main method has changed now. Var model equals new guess the numbers model. I send view and model into it. Now that should work. I can go back to the tests and run it again. It still only calls it, wanted 2 times, but it was 1 time because it's hard-coded. Let's go in here and try to make it as easy fix as possible. I just make sure that it's called twice here. Go back to the tests. Run all the tests. And yeah, this test needs to change also. I need to have a model mock. And let's rerun them. Now we can see that this test fails. The previous test that verifies show guess number fails. And this is good because now the twice test succeeds, but the other one fails because we are lacking behavior here. So in order but this test needs something more in order to work the way that we wanted it to work. We actually want to say that when this is correct, when false when we is correct and we send it a true guess, then return true. Something like that. So now I have 2 tests. The first one is going to be called once. The second one is going to be called twice. But the thing that it changes on is if this is correct, returns true or false. So this one still fails because I have not changed the system. Now I'm ready to change the system. Now I have enough, test things to change the system. So I'm going into the app and I put the thing that is going to change this. If this dot model is correct, and it's going to take a number, hard-coded number right now, 9 or something like that. You need to have a model. This dot model equals model, and it needs to be a field. And what wasn't it called? Is correct. Let's go check how it looks like. It should return a Boolean. Return. And for this particular test, yeah, it needs to be able to compare with something, right? But right now, I don't want to change this. I'm just going to return true here. And this is just a default value, really. Maybe I should have throw new unimplemented exception here instead to make sure that I fix this. Okay, so this one is undefined for the type object. Sorry? Oh, yeah, okay. So this is just, the one error that I introduced, that this is an if statement and not a loop is another error that I'm introducing. Yeah, some. Oh, yeah. and it should be called model. Right, thank you. Blindness. Run these. Okay, and wanted 2 times, what was 1 time? It returns false, and the false, yeah, right. If this is correct, equals false, which is also stupid, right? But it also shows I'm just trying to get the test running, but not writing too much code. And wanted 1 time. Return true. Then this one should return false. So it should not go in here. And it should. It was 2 times still. And it's a model mock that comes in here. And the model mock is saved. And then we call is correct with that one. It should return true. So why is it called twice? A sign of confusion is to run the same code again. Did you know that if you're confused, we're not really believing our eyes. So we tend to do this stupid things of just running the same thing again. Verification in order fails. Wanted 1 time at lecture. And this is also true. So even if we didn't mock it, it would be not go into that. Did I write the code wrong here? If it is correct and false, show guess number. And this one has false, so it should run twice. And this succeeds, so it's running twice. Anyone see the problem?
A sign that you're returning true. You'll be returning.
So the first one, this is a correct guess, right? So we're returning. We define 4 as a correct guess, right? So we are. Oh, maybe it's not sending 4. It's sending 9. So it's not matching this rule. So that is problem. So I had a 9 here, false guess 9, and this one is like 4. So let's run that again. Now it's matching this one. But really, this thing should be any number here. So I think there is a way of doing this. I'm not sure how, though. Okay, now every test succeeds. I can do a little bit of refactoring. And the thing that I want to refactor is that we can see that both of these tests use the view mock and the model mock, and then also calls the constructor with those values. So it would be nice to have those, to remove those and have those as fields in the class, and then also just have these called before each. So in JUnit, you can have a setup method. I usually call it setup. And this method before each is run before each test. So since these are the same for both tests, I'm going to move them here. And I'm going to move both of these up here. Like that. And now I need to tell that this is a view. This is a model. And this is the app. And now I can, this test doesn't need to change. I can just remove these lines of code. I can clean up a little bit better. Something like that. And then we rerun every test, make sure that we didn't destroy anything when I refactor this. I can go into the app and see if I need to change stuff. This is correct. I see that I've hard-coded this number 4, which is not a good thing, right? So instead, this number should be inputted from the user through the console. So we should try to make sure that that happens. So one way of doing that is that we configure the view mock to output a specific value that is not 4. And make sure that the, let's do this. Let's have then return 9, and then we have the view mock get guess. And then I can remove this thing. This means that true guess equals 9. Like that. So now this test should fail because we have hard-coded the 4. So it is not called twice anymore. So I can go and fix that thing. I fix it by inputting a 9 instead here. Go back. Oh, sorry. Go back to the tests. Okay, now that test succeeds, but the second one here should ask for a number twice on wrong guess. So I see that I need another guess, another test where I input something else, or I get something else. So this false guess should also be inputted here. I might be missing something. I think I need another test where I input something else up here. I think so. Yeah. So I'm going to remove this one first, just to take things slow and think of the order. So I need a test that says like this: test void should ask is correct with value sent from get guess from view. And then I have this thing that when view mark get guess, then I return this true guess. And this one. And then I want to make sure that verify model mock is correct, and that true guess is the thing that is sent to it. And right now it succeeds because I have a 9 hard-coded in the system under test. Here, a 9 hard-coded. So here I should have another number like 5. And now it fails because of the reason that I have. No, I'm not calling the view here. Now I can change. I have enough grounds to change the system like this. View get guess that, and I think that get guess is returning and should return an integer, and just have a 0 there to begin with. And I'm in the wrong test now here. And I run. No, that succeeds, that succeeds, that succeeds. Great. Okay. So next thing is that if we get 2 wrong guesses and a correct guess, then show guess number should have been called 3 times. Because we really want to have a loop, and we want not to have this this hard-coded if statement here. We want to make sure to test the loop instead. Should go through. Should continue to ask as long as we are incorrect. Something like that. Then I should have. So we have then return false, and then return false, and then return true. And that should result in 3 times, because we have 1 false guess, 2nd false guess, and then a true guess. As you can see that I can configure the mock object and just add the first call is going to return like this, and then it's going to return like this, and then it's going to work like this. So I can configure that. For this one, I now need to change this test. I should run this test first. And now it fails because it's called twice, because we have hard-coded 2 times. This one up here, I need to change that so we stop the loop. So it should first return false and then return true. And now I can run all tests and see them fail. Yes. And then I can go into the app, and then I can change this. And just see if I can have a while loop. And we go back to the tests and we run these tests, the while loop. and it just continues. Why? Because one of the tests is not ending, I'm guessing. Should ask for a number twice on wrong guess. So we, yeah, how was that done? It was up here. Stop debugging. Go to the code. So not ending is also red. It's a continuing, you know, and it's because I have the wrong code. So I would do it like this: do and inside it we ask first. We ask show guess number while is this better? Something like that, right? So we show greeting, and then we show guess number, and then we get the guess, and we're going to continue this until this is true. So if this is false, and then we go back to the tests and we run them again. I think I have at least one test that should, you know, continue with this. Can I see the output from this? This test is not ending. Then return true. Yeah, the second one. Oh, yeah. Now, I think this test is not, it's not working because we failed to, it needs to have its value from get guess here. So is correct was never called with false guess. It was always called with, you know, the value from get guess. So I need to configure get guess to do stuff. So let's run that and see if that works now. It finishes. This one also needs the same behavior. In order to now I can run it again and it succeeds. So let's see, let's run every test, see if they succeed. We still have should ask if correct sent from view. And that is not, yeah, that also needs to get its value from the view. And it is, yeah, it never stops. So when model is return true, yes, it needs to be like that. Stop debugging. Also stop debugging again. Yeah, that worked. So when I change the behavior, when the behavior is progressively getting more complex, I need to update old tests also. And in the end, I need to look at the tests and see that they are a good suite of tests together. And you can see that it's quite cumbersome to test things Now I have just 4 tests, and I still struggle to make sure that all of these tests are configured in the same way, and it's because I'm changing the behavior. Isn't it better to start to model the application in UML so that you first have a base for what to test and work against that model with your test suites rather than trying to model the application while writing tests? So I think both of these things are good strategies. If I didn't have more or less a clear view on how the application should work, how a model view console application would work, then then it would be hard for me. So then I would benefit from the UML version of the program. And maybe for you who are not inside my brain, this is also a bit confusing, right? Because I'm not fully communicating what I think about the process. Okay. Now I am having all tests passing. Right now, I should run the application in the terminal, and I should see if I can play the game, but I cannot play the game because I have a lot of methods that are not there yet. So when I realize that, I can go to the view, for instance, and see that this getGuess is not yet implemented. So I go to the tests of the view, and getGuess should return input stream values. So things coming into the application usually come through system in. And this is an input stream, so I should mock that one also. I think you probably used console for Java. And I think console is probably the thing that you want to do, but they have finalized that class, so you cannot mock it. So when you're mocking console, you need to wrap console first into your own class. So you have my console, and inside that you have an object of the console class. But I'm going to use the input stream. Input stream mock. And the view needs an output stream, and it also needs an input stream. We make the constructor take 2. Now that one also needs that thing. Yes. Now that I'm starting to copy paste, I realize that every one of these needs the input stream mock also. So instead of copy pasting things, I can always create this before each void setup. Here also, even if I'm not really in a refactor mode yet, I realize that I need this for every part of it. And this should be fields in the class. This one also. Like that, and then we can remove these lines of code from the tests. Yes. So now you see that by having this before each, we're really cleaning up the tests. Okay. getGuess should return the input stream values. So we need to when yeah. So I'm going to call get guess. And then I'm going to assert equals that the expected is the same as the actual. And the expected, we can just put a number here, 56 or something like that. And then we want to configure the input stream so that it returns 56. So when input stream mock dot and now how do I get stuff from the input stream? Java input stream get string. Read line, perhaps. Read line. Right? So you have this buffered reader and stuff. Have you done that? You use scanner still. So I probably want to do something like the buffered reader with the read line. Yeah, I might want to have this buffered reader input instead. Just going to copy it into this one. This input stream, maybe the it would be better to have a buffered reader inputted into the okay, system.console and then read line. Yeah, I'm gonna do this. Yeah, I mean, there are probably many different ways of doing this. So now we have an input stream reader instead, and then we can read line on that one. Then return string value 56. Yeah, so we need rows. What was the error? IO exception. So I get a comment. You should have different views for different tasks. So yeah, so if this application is growing, of course we can have different views. So isn't it better to start the model? Yeah, okay. I think you need to use the input stream reader. Yeah. So right now I switched to buffered reader just because, you know, trying to get somewhere. So, and then I'm making sure that read line should be called with 56, and then I'm getting the value from get guess. So we try that, and it should fail. And that means that we can now go into the view and return 56. Go back to the test, run the test again. Succeeds. That calls for second test of the same thing. And here we are, you know, this is the way that I want you to do it in the assignment. Probably I wouldn't do it like this for real, right? So we could just change this number into 5 or something like that. And then we do it like this. And then I run this test and that fails. And now I have grounds to create the private buffered reader in this in, and let's not call it a mock. In dot read line, and then we have, I think, on the integer or something like that, parse int. And this one, throws IO exception. Yeah, we probably want to rethrow that IO exception. We also get this number format exception. And we should handle that also. We go back to this one. Now that succeeds. The one succeeds also. We can run all our tests. I think that we have a number of things that broke just because we need to throw exceptions on these. Throws declaration, and this one, quick fix throws declaration. Unresolved. Yeah, I guess the numbers view. The main method is also needs to change. This one, the run. Okay, now I realize that one of the behaviors here. Now I could just, you know, be lazy and fix it by adding throws here also. But now I am. I'm just trying to get it to compile, but for the wrong reasons. The true behavior would be that if you input a number exception, that this is not a number, that you inputted something that is not a number, you should get a custom error instead, right? The IO exception is when you're working with a console and you're asking to get some input and they like press Control-C or something like that. That, I think that we should still keep the Control-C thing here. So we're not going to handle that error. But the number format exception, we should not handle that one. I don't have any tests currently supporting me to give an error message and let me, you know, run the application and handle that error. So I cannot currently fix that that bug that we should show an error message unless I add a test for it. So I should go to the app tests and create a new test that says test void should show error message when inputting a string, not a number, something like that. Okay, and then we call run, and we can verify that. I'm just going to remove this one. Show input numbers only, like that. And I want to configure that when view mock get guess is called, then throw new, what was it called? Number format exception. Something like that. This says that if we're getting a number formats exception, then we should show input numbers only. Quick fix, create method. Unhandled exception to a quick fix. This can throw, it's quite okay. Yeah. Run that test. It should fail. It is failing since we get that number format exception, right? And it's not handled. It should be handled, and this one should. So actually, I would like it like this, throws like this, even if it would give me an error message right now. I go back to the application, and now I fix this by having try catch number format exception E, and I need to get the guess inside. Last guess. Like this in order to be able to catch it. Like that. And then inside this one, we call this dot view dot show input numbers only. We need a value for that one. Yeah, this sounds like the easiest solution for that one. You can see that we have in the main here also, I have a compilation error because I've not sent it a buffered input reader. So I should do that. So didn't I have that code here? This one. So notice something in this method, that it is only calling new, right? More or less. and dependency injecting stuff. So this is only calling new. This is factory code. A factory is a design pattern where you create objects. So this tells me that if I have the main method here is just a factory, and if anything is wrong here, when I start the application, it will fail. Okay, so I think that was the changes I need to make. I go to testing, I run all the tests. Let's see if something fails. So I have some continuous behavior, should show error message, doesn't stop. Yeah, and it's because we're asking again for a new guess, and then so we need to have a second call, then return true here. No, yeah. I need to have this one. I need to return true at some point so that we end the loop. So on the second one, and I need to have that true guess. This one. Something like that. Okay, let's stop this test and rerun. But this one should also throw error exception and show error message. Still don't stop. Why? First time, then throw, and second time, then return. True guess. Yeah. Okay, so an observation now is that these kinds of tests where we are working with input and we are working with relationships between input and output gets slightly messy. I think there are probably things that we could do to make it easier on us and to clean things up a little bit. The main should output things. That this test is not ending now because I've not really outputted any. It's never gonna end. This test never ends because I need to input the correct value in order for it to end. And when we implemented more of the system, this is going to be complicated because I probably want a random value to be the number. So in order to have one test that tests the entire system here, I need to have an AI who is playing this game also, right? Which I, of course, can do. For now, my suggestion would be to do it like this, to remove that test, and then say that this done manual. Okay, so I that succeeds. Why aren't these succeeding from the beginning? Okay. All succeeded. If I random Okay, so it was just a timeout issue, I'm guessing. So we're gonna have a break, and I think 15 minutes, and then see each other 11:30. Yeah. So we're starting again. Yes. Okay. So this test class, I felt it grew on us. We're testing this controller, and it felt very, difficult to maintain. That suggests that we are doing something not optimal with our code. So my suggestion would be to rethink this a little bit, and then see what kind of patterns of things we're doing in each of these tests, and see if we can remove some of the things. And I see that we have this true guess and false guess in many places. So I would remove the true guess and false guess and have those as constants in the class, really. And then this model mock is, saying different thing is correct for true guess, then return. So I think this is a behavior that we want to configure for the mock object, that if it sends the true guess, then it returns true. If it sends the false guess, then it returns false. Now, left to do for us is that if we check the different test cases, we can say that, okay, when view mock get guess is called, then return true guess, then, we should end the game directly, and it should say return true here. The second one is we can remove now this line when model mock is correct and return true, because we are just going to return the true guess. So we can remove that one, the case where we are only going through the loop once, right? Then we have the twice. So instead of saying that the model mock should return false and then it should return true, we say that we can remove this thing, and then say that first we return the false guess and then return true guess. I think this is easier to read and easier to maintain also. So we are sort of moving stuff from the tests and exercising the now we have 2 false and then 1 true. Then return false guess, then return true guess, and I can remove that line, which also makes this test easier. And then we have one particular thing. So first, when view mock get guess, then return true guess, then throw number format exception. I think this should be enough for that one. Let's rerun that one and see. First one, it should throw new format exception. Did I need that? This should not be needed, but why did I have this one? So why did I need so many of these? I'm not sure. Okay, all works. Why did I need that one? That worked. This should really be configured like that. Oh, not sure. Suddenly it worked. Okay, but as you can see, I removed a lot of the complexity now by refactoring these tests. So don't forget to refactor tests. This is the key to success here. And when you've learned this enough, I cannot say that I'm there today. maybe I'm there now, but not in the beginning of the lecture. Then we can start writing our tests like this. They are written this clean from the beginning, just because we can, think ahead easier. But don't think that this comes easily to you. You need to practice this, and you probably need to take the long route a couple of times before you can do the short route. Okay. Next thing that we want to do is we want to check. Again, I don't know where I am. So what should I do? I should run the application and see if it works as I would expect it to work. Did it? I'm not getting any real output, right? Something is still wrong, but I have a number of methods not implemented yet. So let's do this one. Should input numbers only, and see if we can get that working. I think that should be pretty easy. It's just one of these tests that we multiply. Should show error for not inputting numbers. Show input numbers only. Remind. Show not number error. Something like that. We go to the view. We have this one. Must be a number. Something like that. Run that test. Okay, wanted but not invoked. Print line stream because we have not implemented it. Go back, run it, rerun it. Okay. There are other things that were not implemented, like this one is correct. So let's start with guess the numbers model tests. By the way, these tests are probably the ones I would start with if I would start working for assignment 1 part 2 today, because these are probably the easier tests. Void should return false on a wrong test. Okay, so let's start with SUT equals new guess the numbers model. SUT is correct. Actual equals this one. Wrong number. Assert equals, assert true I should probably use, right? Like that. Now we need to know the correct number. So either it is inputted here into this one, like correct guess. But that would mean that we cannot, replay the game. And we probably want this to be randomized, a number, because it will be a very boring game. So my suggestion is that we dependency inject random. So in Java, we have, I think, a class called random. Well, rand equals mock random class. Static import for that one. We create constructor in that one. We don't need that static import. And then we say that we configure this random next int. What is it called? Next int? What's the rand? It's called next int. Why didn't it show up? When something like that.
I think it's the same as the inputs you have to wrap the class.
I cannot mock it.
I think I remember this.
Could be. So static or final classes cannot be mocked, I think. Is it not called random? This is some method order. Okay, so I randomly imported the wrong class. Java random. Java util random, it's called. Okay. We need this correct Java util random. Okay, this one. Random generator. So how does that work? Create some mock object. New problem. Missing random. Java util random with the big R. Random. Like that. Should not be. Yeah, maybe I did not. This one is still the wrong type. Java dot better. See if this works. Okay, so this can only mock non-private and non-final classes. So in order for me to mock random, I need to wrap random. So let's do that. Random wrapper. Like that. And random wrapper is something I do. So we have a new file, random wrapper Java. And let's just save that one for now. And this one should change constructor to take a random wrapper instead. And then when I take on the random wrapper, I call next int, then it should return 1. And wrong number is 10, so this one should return false. So we run that test. It succeeds. And why does it succeed? It's not a good thing that it succeeds, but it succeeds because we have hard-coded true here. So I hard code false. I would not do this, but I'm just, because I've just selected one of those. So now it's clear that the easiest way of making this working is this one, which shows that in order for this to work, I need another one, another case where this is, oh, sorry. If I guess the number with the wrong number, it should be false, right? Should return false on wrong number, should return true on correct number. Correct number. Wrong number, we send it to randmock. This one returns. No, this should return the correct value. Oh, I'm getting confused now. Let's start up here. Before each void setup. I can mark this one up there. And then this, whatever I'm inputting here is the correct number. I'm going to use the correct number to return. So next int is going to return the correct number that we're going to have as the secret number. Right? Should return false on a wrong number. And we just take, yeah, let's have the wrong number up there also. And it cannot be the same. It could be, 5 or something like that. So if I'm sending it the wrong number, it should assert false. I think that having the SUT as one of these is a really good idea also. It will clean up this one also. And here, all of these can be removed, is correct with correct number. So this is much cleaner. Now we get an error because we have not yet implemented stuff. This dot rand equals rand. Rand next int. No, we should not have that, right? This is the wrong implementation, but it probably will pass all the tests. So I actually made it out of a mistake, but it's an interesting mistake because probably we are missing a test if our test pass here. Yeah, it's not an object. Equals false, yes. Oh yeah, okay, the random wrapper is int. Something like that. Could be cool. All tests pass, but with the wrong implementation. Shows that we need a better implementation. How can we make it do that? We want to call this more than one time, I'm guessing. So, or I can just say that, I can probably say that this should only be, yeah, let's do it like this. Yeah, there may be many different thoughts here. Well, but we could do it like this. That we're calling this 2 times. Something like that. Should not randomize again. Now, yeah, let's see what happens. That passes still. And it passes still because this one is returning the correct number over and over again. With this, what happens now, if I'm doing that, then it should fail. Because the first time it returns the correct number, the second time it's going to return 99. So this should really be called only once. So in order to fix that, I need to make sure that the next int is only called in the constructor. This correct this correct equals next int. And then we check with these. Yes. Now this should pass, I hope. Now it passes. Cool. And they all pass, so I think I'm done with that. Something is still not implemented, like this random wrapper. This one should really have a random inside it and should return that value. So this is the place where we should have a random instance, and we should create that every time. So how do we test something with random inside it? I would probably run. Yeah, let's write a test for it instead of just talking. Random wrapper tests.java, and then test void should return a number between 1 and 10. Then create the SUT var SUT equals new random wrapper. Put exercise it, next int, assert true, yeah, bigger than 0, maybe we have another. But this is not optimal, because this by default, the random wrapper should provide a random number. So it's hard to do a specific test. But I could do something like this. Int actual equals that. Actual bigger than 0. Actual less than or equal to 10. And then while count less than 1,000. Something like that. Of course, this could be a for loop. Now I run this. It is false because I have not implemented anything. And here we have random. And this one, I think it doesn't take any parameters. Can't I send, a minimum value and a max value? Next int bounds. +1, something like that. Well, why am I having problems with the basics? Java random number generation. Random next int an upper bound. And random next int upper bound. Am I having a problem with my parentheses or what? No, I think just the this one, clean Java language server stuff. Maybe this will help. And when are we getting back? It's still reloading. Here we go. Yeah, so this one passed. So we could have, run it many times and make sure also that the random numbers are almost evenly distributed between the range of 1 and 10. Stuff like that. So even for random output, we can do some limits. I just want to make a point here by having this test. I would say that this test is not super good at finding problems. And the reason for that is that I could create a wrong implementation of this random wrapper that looks like, return 5 or something like that. And it will not find this problem. So if I'm running this test Why? Yeah, it's passing, right? Even with the wrong implementation. Which tells us something that this is not a good enough test suite. But on the other hand, I've been a bit, over testing here. This method is super simple. This method is super simple still. This means that we probably don't need more than one test for it. We will notice if we don't get random numbers when we run the game. Okay, so app. The main method is not called yet, so we need to add an argument. We need a new random wrapper here. And then, is that it? I would run this game also once at least to see if it happens. Something happens. Or guess a number between 1 and 10. It should, give me higher or lower, right? And I just realized that. Because this is quite boring. So, yeah, 9 it was. Of course, the last. So playing the game is actually really good feedback, but it's easily forgotten to start the application when we're doing TDD. So make sure that you can and do run the game also, even if you're working in this particular. I know that it was probably a lot of code just scrolling through, but I want to show you TDD in action a little bit, and also this refactor part. We've also seen that is a super important part of writing tests. And when we have refactored after a while, so this test suite started out quite complicated, but in the end became much easier. So when you divide your or refactor your test after a while, they're going to look fairly similar and fairly simple. So the view test, we've tested, input and output. We've done a lot of mocking. This was a heavy mockist way of doing this. Thank you so much for listening, and good luck on the examinations this week for assignment 1, part 2. Just a short reminder for the students in Växjö, where I gave you the wrong information last week on the when I was in Växjö, and I said that this week we're going to talk about the thesis. We're going to talk about the thesis next week. You're going to get in your schedule. We've scheduled this in a larger room. So I think it's 11:36 or something like that. Okay, thank you very much. See you on the other side.